All right, so to review the scientific method, okay, number 1, observe or state a problem. Number 2, hypothesis. Lewis, you said that was what? Educated guess. Then you design an experiment. And so when you design an experiment, eyes up here please, when you design an experiment, you have a control and you have a variable. The control is what you're looking at without the change. So you're comparing the variable to the control. We have different types of variables, dependent variable and independent variable. The dependent variable is the variable that's being tested, sometimes called the responding variable. You might see that on the test tomorrow. Okay? Independent variable, this is the manipulated variable. So I talked about an experiment with music affecting heart rate. If you change the type of music, that's the manipulated variable. The dependent variable responds to the type of music you're playing. Now I also mentioned another word, constant. Give me some examples of keeping something constant when you have the independent variable. What are the things that you want to keep constant? You can just shout out. Go ahead.
The temperature.
Temperature. Keep the temperature the same. That's usually the number 1 example that you give for that. What else would you try to keep the same?
Light.
The lighting. All right. The battery. That was in a different experiment. Okay. The volume of the music. Did you say volume? Lighting, volume, temperature. All right. So you don't want to play blaring rap music and then the other person is like low volume rock music and they're like, oh, rock music is more calming and the rap music is obviously causing a heart rate. But it could be related to a huge volume and it scares the person versus it's not loud enough and they can barely even hear. Okay. Finally, you make observations, then you record your data on a data table, that was right, and then draw conclusions. Now, here we go. Yesterday we looked at this. There will be something like this on the test tomorrow where you have to look at data. And it will ask you to interpret the data. How many push-ups did this person do on Thursday? Hand up. How many push-ups? Angel. Look.
79.
Not just Thursday.
Oh.
Did 21.
14. Angel is reading the blue dot is right below the 15, so you have to interpret the data correctly. All right? Here is a tough one. What type of chart is this? I don't know if you're going to get this. It is actually not a bar graph. It's almost a bar graph, and I'm going to explain the difference right here. Yeah.
It's a graph.
It is a type of data graph. All right? And it looks just like a bar graph. It is called a histogram. All right? So a histogram has specific data down here, while a bar graph has separate variables marked with each bar. Okay, so that's the difference between a histogram and a bar graph. That's the simplified definition of that. Okay, so could I ask you, if the age group is 16 to 20, how many people like M&Ms as their favorite candy? Ages 16 to 20.
55.
55 maybe, all right, 54, something like that. So you can interpret this data. You see how the bar goes up and it tells you how many people in this group, whatever, okay? So what's this type of chart called? Pie chart, all right. So it looks like a piece of pie. 12% of your life is spent out, going out. 40% is spent at home, and 48% is spent at work. It's called a pie chart because it's divided into pieces of pie. If this was pizza, you would want that part of the pizza, right?
Yeah.
Depends. If you don't like pizza, then you want this part. All right? All right, so what we're going to do now is we are going to do test review. So take out your device, and we're going to play Kahoot. Go to kahoot.it while I load it up. Thank you, Mary.